Hi, I am Angelica Labor, and in this video, we will be showing you an algorithm that basically finds the shortest path in a graph, hence it is used in many fields. Some instances would be computer networking or routing system. The application in Google Maps to find the shortest possible path from one location to the other, and even in biology, where it is used to find the network model in spreading of an infectious disease. Hence the title of the video, Dijkstra's Algorithm. Dijkstra's Algorithm, named after its creator, computer scientist Edgar W. Dijkstra in 1956, is an algorithm that solves the problem of finding the shortest path from a point in a graph to a destination. This algorithm runs on a weighted graph. There are two types of weighted graphs. One is a directed graph and the other an undirected graph. Vertex or vertices are portrayed as nodes while the edges are presented by lines between nodes and the number are their weights. Take note that the weights are always positive and not negative. There should always be a starting node or initial and a goal node.
Sup, I'm Noel Castro, and I'm about to show you the step-by-step process of Dijkstra's algorithm by solving a problem from the internet. Call it Dijkstra or Dijkstra. I'm gonna call it Dijkstra, mostly to avoid being laughed at. So let's begin. For the first step, assign to every vertex an unconfirmed distance value, which will be infinity. Then select a starting vertex, like in this case is A, and set its distance value to 0, because the distance from A to A is 0. Also, determine the goal vertex or destination vertex, which will be E in this example. The second step is to keep a set of visited and unvisited vertices for tracking purposes. Take note that the starting vertex is always the first visited vertex. You can also use a table version of tracking, but I just prefer it this way. In the third step, for the current vertex, consider all of its unvisited neighbors and calculate their distance value using this simple equation. Distance value of the current vertex plus edge weight between current vertex and neighbor vertex. So in our case, A has a value of 0 and the edge weight between A and C is 6. 0 plus 6 is basically 6, and 6 is like a new tentative distance value of C. If this is less than their current distance, replace it with this new value. Same goes with B. The edge weight between A and B is 1. 0 plus 1 is 1. 1 is less than infinity, so distance value of B is 1. There's a letter beside the distance value of a vertex, but that's just another way of tracking of what previous vertex it came from. Step 4. Visit the unvisited vertex with the smallest known distance from the current vertex. Vertex B has the smallest known distance from A, so we visit B. Always remember to mark the current vertex as visited and remove it from the unvisited set. The final step, if the goal vertex has been marked visited, the algorithm has finished. Else, go back to step 3. Repeat the same process again. So get the distance value of the neighboring unvisited vertices using the same simple equation. The current vertex is B. B has a distance value of 1 and the edge weight between it and D is 1. So 1 plus 1 is 2. 2 is less than infinity. So we put 2B. Repeating, the distance value of B is 1. Edge weight between it and C is 2. So 1 plus 2 is 3. We put 3B. Now vertex C has two distance values. So what you do now is compare the two distance values. Again, if this new distance value, which is 3B, is less than their current distance value, replace it with this new value. 3 is less than 6, so we replace 6a with 3b. It doesn't matter what previous vertex it came from, what matters is their distance value. Now visit the smallest known distance value. In this, vertex D has a smaller known distance, so we visit vertex D, then later mark it as visited. As you saw earlier, we proceeded to vertex C rather than just going straight to vertex E, which is the goal vertex, so why not just take the path from D to E? Well, Dijkstra's algorithm is a greedy algorithm, meaning that it will always choose the thing that seems to be the best right now, without regard for how it may impact future choices. Well, that's what the internet said, so there you go. Dijkstra's algorithm. Also, to add something, if for instance the vertices have the same distance value, Dijkstra's algorithm says that you can pick any of them arbitrarily and still find the shortest path. Arbitrarily is just another fancy word for, random pick. Here's the steps of the algorithm. You could just, pause the video and continue with your exam or quiz. So